Right, so in this video, what we're going to do is look at the possibility of substituting something into a transform and maybe getting a different kind of function to transform. Kind of interesting. So looking at the first line, we know that capital F of S is representing the Laplace transform of f of t, which is the integral from 0 to infinity of e to the negative st f of t dt. And that's just the definition of Laplace transform. So if we have f of s minus a, I want to fill in this blank with something, but we'll have to see what it ends up being. So we know by definition, so if I replace s with s minus a, as you see highlighted here, we have e to the negative s minus a times t times f of t dt. Now what I'm going to do is I'm going to multiply this out a bit. So this is going to end up being the integral from 0 to infinity. I'm going to have e to the negative st times e to the at f of t dt. And now all of a sudden, this is the function we're transforming. Maybe not the dt, but this is the function we're transforming. So that means that capital F of s minus a is the Laplace transform of e to the at f of t. Now what does that mean? That means we're going to transform f of t first, and this guy tells us to replace s with s minus a. It seems to be as simple as that. We don't have to crunch through another integral. We don't have to do anything else fancy. So let's just see how this works. So here is our first transform. We're going to take the Laplace transform of t squared e to the 3t. So according to the rule we learned, we take the transform of this, which is 2 over s to the third. And this tells us that s becomes s minus 3. So the Laplace transform of t squared e to the 3t by itself is 2 over s minus 3 cubed. That is really all there is to it. Let's look at another one. Laplace transform of e to the negative 2t cosine of 4t. So again, since there's an exponential multiply to our function, I'm going to focus on this first. The transform of cosine of 4t is s over s squared plus 16. This is telling me that s gets replaced with s plus 2, s minus negative 2. So that means the Laplace transform of e to the negative 2t cosine of 4t is s plus 2 over quantity s plus 2 squared plus 16, which could also be written, if you're feeling motivated, as s plus 2 over s squared plus 4s plus 20. Kind of getting you prepared for the future when we have to actually take the transform and go back. And if there was a shift involved, that's going to be something interesting. So either one of those answers is perfectly fine. Last but not least, here we go. We're going to transform a sine. So that's the function we're going to transform. And this tells us that s becomes s plus 4. So the Laplace transform of sine of 8t is 8 over s squared plus 8 squared is 64. So that means the actual Laplace transform of our function is 8 divided by s plus 4 squared plus 64, which, let's see, if we multiply that out, we could write that as 8 over s squared plus 8s plus 80. And that's all there is to it. So that is taking Laplace transforms of shifted functions, meaning exponential multiplied by the function shifts the transform. Thanks for watching.